Hello there, friends. So another lesson on the Devops Journeyman today. We're going to have a look at command lines interacting with a computer over command lines and terminals. And then maybe we'll take a peek into the starting of your scripting journey. Because as a DevOps person, you want to automate nearly all of the tasks that you can do that are easily repeatable. But you've got to have an understanding of how to interact with the computer first without using a user interface. So what does Windows let you do? So let's go and have a look in here. Um, where I started on Windows was on the command prompt. We can open up a command prompt here. And because this is Windows 11, this has actually opened up the terminal app, which you can have different kinds of command line interfaces in. So here I've got the traditional command prompt. I could add another tab here, and I could also add a PowerShell prompt. And that's a different set of commands that I can run, but we'll go through that in a second. So if I were to do some things on inside the command prompt just by interacting, so I want a list of folders, I do a dir or a directory, and I can see what folders there are. If I use the cd command, I can go into the downloads folder, and then I can do a dir again, and I can see all the files that have been downloaded. I can also find different bits of information from the computer, so I can do a system info, which will dump out a whole host of information about this particular Windows computer. But say, for example, we wanted something specific in there, then I can chain two commands together, and I can do that by doing system info. This little character here is a pipe, and that's send the output of system info into the next command, which we're finding a specific string with findstra, and we're going to look for the total physical memory of the machine. Okay, and so it sends all of that information into findstra, and there we can see the total physical memory kept output as 11979 megabytes. And we can also have a look at lists of tasks with the task list command. And again, if we want to narrow down that list of things to do, we can again use findstra. I mean, this isn't the only way of doing things, but this is a simple demonstration of some of the things that you can do. Let's go. I'm going to pick out the CMD process, for example. So the CMD, that's the process that I'm interacting with at the moment. So I can find the details of the memory, what processor ID of the command is. So you can use the internet to help you, but if you just type help, you can see a list of basic commands there with which you can start to put things together. Lots of help on Stack Overflow, lots of help on, I think SS64 is another website I'd go to for Windows commands. A more up-to-date version of getting information and interacting with your computer is Windows PowerShell. So just like Windows PowerShell, it's a command line interface here. And let's do the equivalent of what we did in the previous command prompt window in PowerShell. So we've got some same commands, some slightly different. So I can, if I did a dir in PowerShell, it will work. The output's slightly different because PowerShell deals with the output of its commands in a very standard way, which makes scripting far easier once you understand it. But it's returning the list of folders. So let's go back into the downloads folder, same command, cd. And if we do a dir, again, here you can see all of my files that I've downloaded. That's cool. If I wanted to get the memory, this is where things change. I can use the command get computer info. And just like in the command prompt, I can use the pipe to send the information from one command into another. But this time we're going to use, instead of find strip, we're going to use select object. And if there's interest, I can do some videos around PowerShell. I'm probably going to move on to more Linux, Unix, POSIX command shells at a later date because they're the ones I interact with more on a day-to-day basis, just because DevOps people tend to do stuff more on Linux and Bash and Macs and things like that, but I'm trying to stick to Windows for now. And I can use Bash on Windows, but I haven't set it up yet. So there you can see I've got the memory. It's coming out in a different format, but the memory here is coming out. I can also do a task list, but this time the command's called get process. So if I do the get process, I see a load of process stuff. And then if I do get process and I feed in, I want to select an object, CMD. Oops. Got that command wrong. Hold on. Let's just minus name CMD. Oh, rubbish. Get process. I was hoping that it would pick out that same CMD process. And I don't quite sure. Actually, if I just do a get process CMD, there you go. I don't have to pipe that information into another command to get that. Now, say for example, you want to run that check or these checks every day. Logging in on the morning to your computer, it's just going to be long and laborious and repetitive. So what we can do is we can start to automate those things. And what we do is we write text files with those commands pre-populated. So say for example, we'll do those exact same commands. We'll check the memory, we'll check the processes of a thing. And we can, if we put that into a text file and then we run the text file, that's our first script. Okay, so all right, how do we start doing that? So what we're going to do, I'm going to go up a folder and I'm going to make a new folder called source. Oh, come on. Oh, it already exists, that's why it's not there. And I'm going to make a directory called scripting examples. Okay, and we're going to go into that. So all of our scripts I'm going to put into this folder. ED scripting examples. There we go. So we could write our scripts using Notepad. First example. And if we're writing batch scripts, on Windows we call them .cmd files. So we can use a Notepad. It's asking us to create a file. If you just want to write a line, you can do echo. You can write echo hello world. And in fact, we're getting a bit of cleanup. This first line means it doesn't show the command as well as the output of the command. So that should just type. So if I click save, so then if I run that command, first example, see, it just dumps out hello world. Whereas if I took out that at echo off, save it. Is it misbehaving? And we're going to go scripting examples. And then we're going to go first. Well, the echo off is not making any difference. Okay, ignore me there. Just something I used to do in the past. But Visual Studio Notepad, a bit clumsy. What we're going to do is we're going to open up Visual Studio Code because that's a much better environment for doing little scripts and things. And we're going to open up that folder. So we've created that scripting examples folder in C users date source. Can open up that folder. And there we can see our first example with Hello World. Okay. So now let's do a new file, morning report, morning report.cmd. Okay. And what we'll do is we'll write a quick script. Now I'm gonna cheat a little bit and I'm gonna cut and paste this from a previous script. And we'll walk through this line by line. Let's get rid of that window. So here you can see, so a rem command is basically a comment. So Windows will ignore that, but it's good for making notes. Anytime you see an echo, that's usually an output to your command line. So starting morning system check, it's going to show that. And then you can see here, you can see each of the separate commands that we can use to display different bits of information. Now we could run that in this terminal. In fact, I'll do it both ways. I'll run that in this terminal. So this is morning report. So you can see it's collecting some information. So it's run each one of those 5 commands separately without me having to run anything. But as you can see, as you can see here, it's the output's not very easy to read because that at echo off isn't there. So let's put that back in. Right, and rerun it. WMIC doesn't exist on this machine. But here you can see so if that errors, let's get rid of that. Let's not do that check. Okay. Now Visual Studio Code, as you can see, it's auto-saving my file, so I don't have to remember to save it every time I check. So here you can see that's a lot better, that bit, the way the output's coming out. Okay, but Visual Studio Code is quite nifty in that you can have a terminal window inside here. And CMD files happen to be able to run in both the PowerShell and in normal command prompt windows. You can change it in here. You can change, or you can add different kinds of terminal windows. So you've got PowerShell. Because we installed Git the other day, or on a previous tutorial, we've got Git Bash, but it can do command prompts. Let's run this on the command prompt. And if we do morning report, there you can see it's running inside Visual Studio Code. So you don't even have to leave Visual Studio Code if you don't want to. Okay, so you might see me do a lot of hopping around between windows. And let's run it in PowerShell. We'll run it in the PowerShell terminal just to prove that it does run. See, it's, Windows is smart enough to know that it's a batch, it's a Windows command file and how to run it. It knows how to deal with that. Okay, so that's your first simple script. So it's outputting some data, so that's pretty cool. Now I could rewrite that in PowerShell. It looks a bit more verbose. So if I do morning report dot ps1, no, yeah, do that one. Right. So I've got this example, and now because PowerShell is newer than CMD Windows, it's less likely to work. You can tell whether or not you're in a PowerShell window versus a command window in that the prompt, you've got PowerShell at the beginning, PS, whereas in a command window, there isn't anything. If you were in the command window, you would have to specify, you'd have to probably run it like PowerShell morning report dot ps1 like that, but I'm not going to do that because if we're writing PowerShell, I'm going to stay in PowerShell. And on first run, I don't think this is going to work first time because Windows likes to try and be secure by default when it's installed out of the box, so it doesn't let you execute PowerShell scripts natively, and you usually get this cannot be loaded because running script is disabled on this system, particularly PowerShell scripts. Like the bash scripts, the command scripts are running, but the PowerShell ones aren't. To get them running, and bear in mind, you should go and check that you're happy to set things in this way. And I'm going to change that. Go and have a look at what set, you search on Google for what set execution policy means in terms of there are different levels of security you can apply. I'm just going to open this up completely because I sort of know what I'm doing sometimes. I just need to check what the field is. Where unrestricted. So if I put unrestricted in there, right, that means any PowerShell script from anywhere can run on my machine. Run morning report, and now it's again slightly different format, but there's loads of stuff coming out now from in PowerShell in exactly the same querying for exactly the same kind of data. Now the strength of scripting means that everything is repeatable. You can run the same commands over and over again. The script itself is a document of what you do, so anybody else can read it and see what it does. Speed, I don't have to write all of the commands individually. I mean, this is a 29, like the PowerShell script is a 29-line script. I don't have to write 29 lines. I just have to write the one command to execute it. And I can also add error checking and things so that it'll still carry on. It doesn't just stop and blow up if an error gets experienced. Okay, so that's kind of like the first few basics of scripts and things. And then we start getting into, well, you can start to add logic to those scripts. So you can read these bits of information and you can then test them to see whether or not you're happy and then do actions based on whether or not you're happy or not of certain things coming out. So, for example, you could have a backup folder, and if the backup folder doesn't exist, then the script can go and create it, as an example. We have the concept of variables. We can store information in scripts. So let me just see if I can write a quick example. So we'll do this in batch first. So logic example, we'll call this one. So we'll do the @echo off at the top. we'll create a couple of variables. So we're going to do backup folder equals C / users. So my user on here is called Dade. Backup. So we're going to test to see whether or not that backup folder exists or not. Let's see if I can do right, so this is where I quite often go onto the internet because I can't remember. Windows command script if folder exists in batch rather than PowerShell. So that's why I picked this one. So there we go. So if exist your folder name, right? So let's do, so if exist, so that, what that's doing there, I'm going to get rid of that underscore folder because that's a bit confusing. So what Windows will do here is it will search and replace this with this value, which means you can change that value lots and lots over and over, to lots of different things through scripts and do different actions based on different variables. And what we'll do is we will, if exist, I just have to check the syntax because I'm in lots of different languages, so I quite often get mixed up between the languages. Right, I'm doing else. This is why we start having to think about programming logic and things. So I'll do if exist, so we can say, all right, message folder exists, do nothing, echo message folder doesn't exist, create it. Folder doesn't exist. And then we just do a make dir backup folder, percent backup folder, percent. Okay, so let's go to a batch window. We'll clear that down. CLS, clear that down. And then we go /logic example. Okay, so you can see here my script found the fact that that folder doesn't exist and then tried to create it. Okay, now the evidence of that is, let's go and have a look at this, where this folder lives. So in C users Dade, C users Dade. There we go. We've got a backup folder which got created a couple of minutes ago. Awesome. So any information that you can get on the command line, you can then build some logic around, write a script to do it. So there we go. When you're writing scripts, try and think ahead of things that might happen. So as a person that writes scripts all the time, constantly think to yourself, well, what could go wrong? Like, what would happen if the folder already exists, but the command to check whether or not it exists, whether or not that goes wrong? What would happen if what happens if there's spaces? How do you know if it worked? So you could put another check in here to see whether or not it then created. And then you have to work out what would happen if the script fails and what information would help the next person. So, those are kind of the basics of, without going into too much depth of, here's how to script. That's kind of like a fairly basic example of stuff that happens. What I'll do is I'll stick these early scripts into a GitHub, and I'll link those to the bottom of in the description of this video. We'll go into, as we go into Bash and other terminal windows on other machine, other types of machines, we'll go a lot deeper into scripting. But for now, I think that's what we're going to do. So the key takeaways here are that scripts are just basically a list of commands to run. And they make your work repeatable and shareable, because I can send this to anyone. I can send this to one of my colleagues or my family. Adding logic is the real strength, is the real secret sauce of why you would write scripts. And then you could add logging to make things easier to troubleshoot. Do that all the time. The key thing here is to start simple and gradually grow in complexity as your confidence gets better. Stack Overflow, Google searches, AI, they can help you build out these scripts really nicely if you really want to. And every script you write is documentation for future me. I always tell people I work with, the reason why I write scripts, or how I write scripts, is I try and write them in such a way that even if I've forgotten them, I'll be able to read them back in 6 months' time, to make them nice and supportable. So there we go. That's scripting and command lines and terminals in a nutshell.